we have seen information about the entropy. For a spontaneous process or an irreversible process, delta S, the entropy change, has to be positive. That's a condition for a spontaneous process. Using entropy, two more functions have been proposed. One is called what is known as the work function A. And another is free energy, denoted as F or G. You may wonder, why do you need two more functions to predict about the spontaneity? Already you have found out a condition, delta S has to be positive for a spontaneous process. Delta S positive means it has to go from order to disorder. However, there are some reactions, polymerization, formation of a protein from amino acids. They go from disorder to order. So delta S is negative for such a process. But those processes are also spontaneous. Therefore, we need another function to predict about the spontaneity and the equilibrium. So using entropy, they have proposed two functions. One is known as the work function, other is known as the free energy. Work function A is defined as E minus Ts. This is the definition for work function. That E is the internal energy, T is the temperature, and S is the entropy. And A is a dA is a complete differential or an exact differential. A is an extensive property. These are the properties of A. Let us consider an isothermal change. Temperature remains constant. It goes from state 1 to state 2. So A1 equal to E1 minus Ts1 and A2 equal to E2 minus Ts2. Since it is isothermal, temperature remains the same. And delta A, A2 minus A1 is equal to E2 minus Ts2 minus E1 minus Ts1. E2 minus E1 minus T into S2 minus S1, or delta A is equal to delta E minus T delta S. We know Q reversible by T is equal to delta S, or T delta S equal to Q reversible. So I can write this as delta A equal to delta E minus Q reversible, or minus delta A is equal to Q reversible minus delta E. According to first law, Q minus delta E is the work done. So this is equal to reversible. So now you get a meaning. The decrease in work function gives you the work done by the system, the reversible work done by the system. So if you know the work done, you can predict the change in work function, or if you know the change in work function, you can calculate the work done by the system, reversible work done by the system. The next function is free energy, denoted as F or G. This is defined as F is equal to H minus Ts. H is a state function, S is a state function, so F is also a state function. That's a definition. Or I can even write F equal to E plus PV minus Ts. E minus Ts is nothing but A. So I can say F equal to A plus PV. As it is, it doesn't convey any meaning. But suppose there is a change from state 1 to state 2. I write it as F2 minus F1. It is A2 plus PV2 minus A1 plus PV1. I have presumed that it is a constant pressure process. That's why in both the cases, the pressure remains the same. Or delta F equal to A2 minus A1 plus P into V2 minus V1, or delta A plus P delta V. Again, F is an extensive property, state function, and dF is a complete differential or an exact differential. Again, this doesn't convey any meaning to us. Let us probe further. I can write it as delta F equal to, I know the meaning for this delta A. Delta A, just we have seen, minus delta A is the work done by the system. So I can write it as delta F is equal to W reversible plus P delta V. Let me change the sign. Minus delta F equal to W reversible minus P delta V. Delta F equal to, we know delta A equal to minus W reversible plus P delta V, or minus delta F equal to W reversible minus P delta V. W reversible minus P delta V means work except the pressure volume work, expansion work. So this is the net work done by the system, work other than the expansion work. So I can write it as minus delta F equal to W reversible prime, where W reversible prime is the net work done by the system other than pressure volume, expansion work. So this is the meaning for delta F. So the decrease in free energy will give you the net work done by the system, or work done by the system other than pressure volume work. That is the meaning of this term. Okay, we will talk about some of the relationships involving work function and free energy. A equal to E minus Ts is the definition for the work function. Or dA equal to dE minus TdS minus SDT. According to first law, Q minus dE is equal to PdE. This is according to the first law. And we also know that Q reversible by T is equal to ds, or Q reversible is equal to TdS. So let me substitute this value of TdS in this equation. dA equal to dE minus Q reversible minus SDT. We know that according to first law, Q reversible is equal to dE plus PdV, or Q reversible minus dE is equal to PdV, or dE minus Q reversible is equal to minus PdV. So I can write it as dA equal to minus PdV minus SDT. At constant volume, PdV equal to 0. So I can say dA at constant volume is equal to minus SDT, or dou A by dou T at constant volume is equal to minus S. At constant temperature, SDT becomes 0. So dA is equal to minus PdV, or dou A by dou V at constant temperature is equal to minus P. So these are two important relations regarding the work function. It's meaningful also. Keeping the volume constant, if you change the temperature by 1 unit, what is the change in A? That is equal to the entropy of the system, negative value of the entropy of the system. Similarly here, keeping temperature as constant, if we change the volume, what is the change in the work function? That must be equal to the negative sign of the pressure of the system. So these are certain relations. We need these two equations. I make a note of it. Dou A by dou T V is equal to minus S. One more equation is dou A by dou V at constant temperature is equal to minus P. Okay, we will use it later on. Now let us try to derive similar relationship for, this is for work function, similar relationship for the free energy. So F equal to E minus Ts let me F is equal to H minus Ts is the definition, or F is equal to E plus PV minus Ts, or dF equal to dE plus PdV plus VdP minus TdS minus SdT. This is the general differentiation case, only this. Now, I can say that dE plus PdV, according to first law, is Q. By definition, Q reversible by T equal to Q reversible by T is equal to ds. Therefore, TdS equal to Q reversible. So, Q plus VdP minus Q minus SdT, or dF equal to VdP minus SdT. So I can derive two more relations now. At constant pressure, dP equal to 0. Therefore, VdP equal to 0. dF equal to minus SdT. Or dou F by dou T at constant pressure is equal to minus S. I'll make a note of this equation also. Dou F by dou T P equal to minus S. Similarly, at constant temperature, dt equal to 0. Therefore, SdT equal to 0. So, dF at constant temperature will be equal to simply VdP, or dou F by dou P at constant temperature equal to V. So, this is another important relationship which we need. I will make a note of this also. So, I need these four equations later on. From this equation, it is possible to calculate. Let me write this again. dF T equal to VdP, or dF T equal to RT by P dP, or dF T equal to RT dP by P, or dF is equal to RT d ln P, or delta F equal to RT ln P2 by P1. So you can calculate delta F if you know the pressure values. Now we look into an important equation known as the Gibbs-Helmholtz equation. This can be derived in many forms. The basic form is F is equal to H minus Ts. This is the basic form of the Gibbs-Helmholtz equation. For minus S, I can use this relation. Minus S is equal to dou F by dou Tp. Therefore, I can write F is equal to another important equation in various forms we are going to derive. The equation is known as the Gibbs-Helmholtz equation. And F is equal to H minus Ts, is the simplest form of the Gibbs-Helmholtz equation. And for minus S, I can substitute this. So it will be F is equal to H plus T into dou F by dou T P. This is another form of the Gibbs-Helmholtz equation. Let me divide this equation by T square. F by T square equal to H by T square plus 1 by T into dou F dou T P. Take this H by T square to this side, minus H by T square is equal to minus F by T square plus 1 by T into dou F by dou T P. The right hand side is nothing but, so minus H by T square is equal to, this is nothing but differential of F by T by dou T P. You can check it. It's a very simple relation. Differential of U by V is nothing but V du minus U dV by V square. Use that equation, you will get this information. I am not doing it here. So this is another form of the Gibbs-Helmholtz equation. This is the third form. And instead of H and F, I can use delta H and delta F minus delta H by T square is equal to delta F by T by dou Tp. So there are four forms of the Gibbs-Helmholtz equation. I can derive similar equations with the work function also. I am going to derive similar equations with work function. A equal to E minus Ts. We have a relation for minus S. Dou I dou Tv is nothing but minus S. So let me substitute that here. So A equal to E plus T into dou A dou T V. This is another form of the Gibbs-Helmholtz equation. Let me divide this by T square. It will be A by T square is equal to E by T square plus 1 by T into dou A dou T V. Bring this E by T square on this side. So minus E by T square is equal to minus A by T square plus 1 by T into dou A dou T V. The right hand side is nothing but differential of A by T by dt. So I can write it as minus E by T square is equal to differential of A by T by dou T at constant volume. Similar relationship can be derived for delta E by T square equal to differential of delta A by T by dou T at constant V. So all these are forms of the Gibbs-Helmholtz equation. Now we will look into the condition for spontaneity and equilibrium. In terms of entropy, we know the condition for spontaneity and equilibrium. ds is equal to q by t for reversible. In other words, equilibrium. And ds is greater than q by t for irreversible. In other words, for spontaneity. So combining, I can say Ts is greater than or equal to q by t. This is the condition for spontaneity and equilibrium in terms of the entropy. Now we will find out the condition for spontaneity and equilibrium in terms of work function and free energy. We know that the work function A is equal to E minus Ts, or dA equal to dE minus TdS minus SdT. Okay. For equilibrium, we know the condition TdS is equal to Q. So I can write it is equal to dE minus Q minus SdT, or dA is equal to dE minus Q is minus PdV. According to first law, Q equal to dE plus PdV, or dE plus W. Therefore, dE minus Q is equal to minus PdV. So dA equal to minus W or PdV, whatever I can, anything I can write. W minus SdT. For a constant volume and temperature, it is equal to 0. So the change in work function is equal to 0 for equilibrium, for a reversible process. If it is a spontaneous, irreversible process, I will write as dA equal to TdS will be greater than Q. So this quantity will be greater than Q. Therefore, dA equal to dE minus Q minus SdT. Just now we have seen that. Let me write this also. dE minus TdS minus SdT. Actually speaking, this will be greater than TdS. If it is greater than TdS, this quantity dA will be less than 0. For reversible, it will cancel off. So the condition is dA is less than or equal to 0 for a spontaneous and equilibrium process. So there should be a decrease in work function for spontaneity, and the change in work function should be equal to 0 for equilibrium. Now let me find out in terms of the free energy F. F equal to E minus Ts plus PV, or dF equal to dE minus TdS minus SDT plus PdV plus VdP. If it is a reversible process, TdS is equal to Q. So I can say dF equal to dE minus Q minus SDT plus PdV plus VdP. dE minus Q is nothing but minus PdV. So minus PdV minus SDT plus PdV plus VdP. So this will cancel off. So dF will be equal to VdP minus SDT. This is for reversible. For irreversible, just now we have seen TdS will be greater than Q. TdS will be greater than Q. So this quantity will be greater than Q. So I will write that dF will be less than VdP minus SDT. Or for constant temperature and pressure, this will be less than 0. So the change in free energy will be less than 0, means it will be negative. So change in work function will be negative for spontaneous, and change in free energy will be negative for spontaneous. So in terms of entropy, it is positive for spontaneous, and free energy and work function, it will be negative for spontaneous.